children, let us discuss about the general chemical properties of group 17. Yesterday already we discussed one of the property, that is oxidizing nature of halogen. Today let us continue with the second property, that is reaction with hydrogen. All the halogens, that is group 17 elements, react with hydrogen and produces corresponding halides, hydrogen halide. That is, all the halogens react with hydrogen and produces corresponding hydrogen halides. And you know that the stability of hydrogen halide decreases, or affinity for hydrogen decreases from fluorine to iodine. Is it clear, children? This hydrogen halide, when dissolves in water, it results in the formation of hydrohalic acid. You will be getting corresponding acid. The affinity for hydrogen decreases in the order, and you can also see that the acidic strength also goes in the order HF, then comes HCl, HBr, HI, etc. This is the change in the order of acidic nature. At the same time, you can see that as we move down the cities, that is, the thermal stability of this hydrogen halide decreases. That is because of decrease in bond dissociation enthalpy. Children, this same thing we have discussed in other groups, group 15 as well as in 16. So we can say that the thermal stability, the acidic nature varies in this order, but thermal stability decreases as you move from, that is, HF to HA. This is the order of thermal stability, and that why the thermal stability decreases like this, it is because of decrease in bond dissociation enthalpy. Okay, children. Third one we can consider reaction with oxygen. All the halogens react with oxygen and produces corresponding oxides. For example, if you consider fluorine, fluorine reacts with oxygen and produces O2F2 and OF2. This OF2 is thermally stable at 298 Kelvin. OF2 is thermally stable at 298 Kelvin, but both these compounds are not termed as oxides. They are termed as fluorides because of high electronegativity of fluorine. Is it clear, children? That O2F2 and OF2, they are termed as fluorides because of high electronegativity of fluorine. This compound, both of them act as good fluorinating agent. Okay, they act as good fluorinating agent. O2F2 can be used to oxidize plutonium as PuF6. That is, then you can remove Pu from the spent nuclear fuel. Is it clear, children? So that is about the oxides of fluorine. Now, if you consider chlorine, chlorine forms the oxides like Cl2O, ClO2, Cl2O6 and Cl2O7. These are the general oxides of chlorine. And these oxides are highly reactive and they explode on heating. And they are very good oxidized. And particularly if you consider ClO2 is a very good bleaching agent which can be used for bleaching wood pulp, cotton, textile, etc. Is it clear, children? Now, if you just consider in case of bromine, bromine forms oxides like Br2O, BrO2, BrO3, etc. These are the oxides of bromine, and these oxides are generally stable only at low temperature. They are stable only at low temperature, and they also act as good oxidizing agent. If you consider iodine, iodine forms the oxides like I2O4, I2O5 and I2O7. Is it clear? These are the general oxides of iodine, and out of this I2O5 is particularly a very good oxidizing agent, as well as it is used for the estimation of carbon monoxide. Is it clear, children? That is about the reaction of halogen with oxygen. In addition to this, halogens also react with metals and produces metallic halides. Or if you consider reaction with halogens, reaction with metal. Halogens react with metals and produces corresponding metal halides. For example, if you consider that is magnesium reacts with bromine and produces magnesium bromide. Is it clear? Magnesium reacts with the bromine and produces magnesium bromide, and we can say that the ionic nature of this halide decreases as we move down the group. Is it clear? Ionic nature decreases. Here we have to tell one more thing. If the metal shows different oxidation state, then the one which is having higher oxidation state will be more covalent than the one which is having lower oxidation state. For example, if you consider PbCl4 and PbCl2, in this case, the oxidation state of lead is higher compared to the second compound. So this compound PbCl4 will be more covalent compared to PbCl2. The same is like SnCl4 and SnCl2. Is it clear, children? That is about the property of halogens with metals. Now fifth is a very important reaction property. We can say that halogens have a tendency to react with another halogen. That is, we are going to study about reaction of halogen with another halogen. That is here, when two halogens react with each other, it results in the formation of a group of compounds called interhalogen compounds. Is it clear, children? When two halogens react with each other, it results in the formation of a group of compounds called interhalogen compounds. This interhalogen compounds may have the formulas like XX1 dash, XX3 dash, XX5 dash, XX7 dash, where X will be of larger atomic size and higher electropositive nature. Both of them are halogen, and in which X will be having larger, the size of X will be more, and it will be more electropositive than X dash. And as the ratio between the radii of these two halogen atoms increases, the number of atoms present per molecule also increases. Is it clear, children? When two halogens react with each other, it results in the formation of a group of compounds termed as interhalogen compounds. In this, X will be a halogen of larger size and X dash will be of smaller size. At the same time, X will be more electropositive compared to X dash. Is it clear? And as the ratio between the radii of these two atoms increases, the number of particles present per molecule also increases. In order to prepare this, you can just by direct combination of halogens, by treating it with another interhalogen compound, you can prepare them. For example, if you consider Cl2 plus F2 at about 473 Kelvin, you will get ClF. But on the other hand, Cl2 plus 3F2 at about 573 Kelvin, you will be getting ClF3. So this is how you can prepare interhalogen compounds. Is it clear, children? These compounds are highly volatile in nature. They are volatile solids or liquid except ClF. ClF is a gas. Okay, they are volatile in nature as well as they show diamagnetic nature. They will be showing diamagnetic nature. Their physical properties will be lying in between these two halogens, but they possesses generally a little high melting and boiling point compared to the particular halogen. Is it clear? Chemically, we can say that X dash, interhalogen compounds are more reactive compared to the original halogen. The reason is that X dash bond is generally weaker than XX bond. Is it clear? X dash bond is generally weaker than XX bond other than FF bond. So we can say that generally interhalogen compounds are chemically more reactive than halogens. And at the same time, this XX dash reacts with water and generally it produces HX dash and HOX. Is it clear, children? That is about the chemical properties of interhalogen compounds. If you consider the structure, XX3 dash generally possesses a bent T-shaped structure. They have a bent T-shaped structure. XX5 dash possesses a square pyramidal structure and XX7 dash possesses a pentagonal bipyramidal structure. Is it clear, children? That is about the chemical properties of halogen. In next period, we will be studying about the methods of preparation and properties of chlorine and hydrogen chloride. Thank you, children.